Wissenschaftlerinnen und Wissenschaftler gewinnen konnten. Wir werden heute gleich im Anschluss starten mit Pierre Dillenbourg von der Universität Lausanne, der sehr einschlägig bekannt ist für seine Forschungsarbeiten und seine Entwicklung von künstliche Intelligenzanwendungen in Bildungskontexten. Am späten Nachmittag heute hören wir Gail Sinatra von der University of Southern California, die Frage stellt, ja, was können pädagogische Psychologen eigentlich beitragen, um den Klimawandel, die Krise zu adressieren, abzuschwächen? Welche Rolle kann pädagogische Psychologie darstellen? Dann am Dienstag konnten wir Manu Kapoor von der ETH Zürich gewinnen, der eine Keynote halten wird über die Frage, wann Failure produktiv sein kann und unter welchen Bedingungen. Und am Mittwoch kommt Patricia Jennings von der University of Virginia, die über ihre Arbeiten zu achtsamkeitsbasierten Interventionen im Bildungskontext sprechen wird. Die Keynotes heute werden online stattfinden und die Keynote am Dienstag und am Mittwoch wird in Präsenz stattfinden, alle hier in dem Max-Planck-Hörsaal. Und es wurde gesagt, eine Tagung lebt vom Austausch innerhalb der Sessions, aber auch darüber hinaus. Besonders eignet sich für Interaktion natürlich die Poster-Session, die heute Abend stattfinden wird. Da ist zu sagen, es gibt einen Publikumspreis, der vergeben wird, also kommen Sie alle, Sie werden ein Getränk und einen Snack bekommen und können voten und mit den Kolleginnen und Kollegen in den Austausch kommen. Am Dienstag dann die Mitgliederversammlung und die Jungmitgliederversammlung auch hier in diesem Hörsaal. Und dann haben wir abends natürlich, ich will nicht sagen den Höhepunkt, aber ein Event, ein ganz besonderes, schönes, hoffentlich soziales Event in der Wunderino Arena, dem Zuhause des THWs. Und wenn Sie darüber hinaus Austausch suchen oder den Kopf frei machen wollen, wir haben gehört, Kiel ist eine Stadt am Meer, dann empfehlen wir auch für zwischendrin einen Spaziergang an der sogenannten Kiellinie, wo Sie links an Kunsthalle, Seehundbecken und dem Landtag von Schleswig-Holstein vorbeikommen. Wenn Sie nach links schauen, schauen Sie nach rechts, können Sie baden gehen am Badesteg vor dem Mobi. Die Wassertemperatur beträgt gerade 19 Grad, haben wir nachgeguckt. Das ist für Kieler Verhältnisse sehr einladend. Da wird auch noch wirklich viel gebadet. Sie können aber auch da einen Kaffee trinken gehen oder sich weiter hinten in der Seebar Subs ausleihen und einmal so Kiel vom Wasser betrachten. Sollten Sie mehr Zeit haben, würden wir einen kleinen Ausflug mit einem der Fördedampfer empfehlen. Sie können auf die andere Seite fahren, nach Mönckeberg oder nach Möldenort oder hier, was Friederike Zimmermann schon erwähnte, mit der kleinen Adlerfähre über den Kanal. Aber überall ist gesagt, Vorsicht vor den Möwen, die sind auch auf der anderen Seite sehr aktiv und freuen sich immer über Zugezogene, Zugereiste und Gäste von extern. Aber zurück zur Organisation und zur Tagung. Abschließend ist noch zu sagen, also Sie haben alle diesen Flyer für die Basisinformationen bekommen, wo so der Programmablauf, die Räume sind, also die Keynotes sind alle hier. Die meisten anderen Veranstaltungen sind in der Leibnizstraße 1 oder gegenüber in der Olshausenstraße 75. Dort gibt es dann auch Kaffee und genau, wenn Änderungen im Programm auftauchen sollten, finden Sie das im Conf-Tool. Und für alle weiteren Fragen finden Sie hoffentlich Hilfe in unserem Tagungsbüro in der Leibnizstraße 1. Und im Programm ist es so, wir haben uns die Freiheit genommen, dass wir die Chairs zugeteilt haben, immer, glaube ich, die erste Person, die in der Session spricht. Also seien Sie als Chair aktiv, kommen Sie rechtzeitig, halten Sie die Karten hoch und genau.
Ja, damit sind wir auch am Ende der Eröffnungsrede. Wir danken ganz herzlich nochmal im Namen des Organisationsteams allen, die beteiligt sind. Das sind natürlich auch die vielen Menschen im Hintergrund, die dafür sorgen, dass diese Tagung reibungslos stattfinden kann und ablaufen kann. Und es ist mir nicht möglich, alle Namen aufzuzählen, deswegen geht das jetzt so ein bisschen, ihr wisst, wen ich anspreche, ne, an alle Statusgruppen sozusagen in der Verwaltung, in der Technik, vom IPN, Social Media Team, auch die ganzen Hilfskräfte, die Hörsaaltechnik. Aber es geht natürlich auch ein Dank raus an die ganzen GutachterInnen, an die Beitragenden, also auch an Sie. Und in diesem Sinne, wir freuen uns jetzt sehr auf den gemeinsamen wissenschaftlichen Austausch und auch darüber hinaus. Ja, allen eine gute Tagung. Bitte laufen Sie nicht zu weit weg. Die nächste Keynote findet in diesem Hörsaal statt. Also bitte bleiben Sie ruhig hier. Es geht direkt weiter. Danke.
Hello.
Pierre, can you hear us?
Yes.
Oh, great.
Great. Hi. Nice to see you. I hope the technique will work just finely. We are checking the
You have to allow me to share my screen.
Just to give you an impression, we have around 400 people in the room right now.
So, laufen Sie nicht weg, der Keynote-Speaker ist schon da. Und wir könnten dann schon auch gleich beginnen mit der Keynote. Je mehr Zeit ist dann hinterher für einen Kaffee. Okay. Now you're on a large screen so everybody can see you. Can you hear me? No.
Yes, but you have to give me the authorization to share my screen.
Yeah. Is it possible? Yeah. Yeah. Ist es freigegeben?
Ja.
Yeah. Pierre, I will start with a short introduction of you, and after that you can start.
Ah, okay, nee, das machen wir weg, ne? Die Selbstansicht machen wir weg. Genau. Wollen wir ihn hier so reinsetzen? Ja, ne? Oder vielleicht nach, sieht man das noch? Ja.
Verstehen, wenn ich hier reinspreche. Ne?
Ja, mich verstehen. Ja. Wenn die Zoom-Sitzung, wenn da alles
Ja.
ist, alle Mikros an.
So Pierre, can you hear me?
Yes.
Yeah, okay, great. Okay. So we can start with the first keynote of our conference here in Kiel. It's my great pleasure and honor to introduce Pierre Dillenbourg, who intended to stay here with us, but because of health reasons he cannot be here. But I'm very happy that Pierre is now online to give his keynote via Zoom, and he has already shared his slides so that we will be able to follow his presentation. Let me say some words about Pierre Dillenbourg. He started as an elementary school teacher and then graduated in educational science in Mons in Belgium. And in 1986 already, he was one of the first in the world to apply machine learning to develop a self-improving teaching system. So about 40 years ago, we are talking today about machine learning and its potential in educational psychology. Pierre did it already about 40 years ago. He obtained his PhD in computer science from the University of Lancaster in the UK, and he worked at that time already in the domain of artificial intelligence applications for education. He has been an assistant professor at the University of Geneva, and he is now full professor at the École fédérale de Lausanne. This is the French counterpart to the ETH, the ETH in Zurich. I think this is a special issue of Switzerland. When you have a German-speaking institution like ETH, you must also have a French-speaking institution in Lausanne. Pierre is their full professor. He's in the School of Computer and Communication Science, where he's head of the so-called Chili Lab, Computer-Human Interaction for Learning and Instruction. He has several other positions and functions at the university. With his colleagues, he launched in 2017 the Swiss EdTech Collider, an incubator with 80 startups in learning technologies. He co-founded 4 startups. He has a lot of consultancy jobs, and I think from my point of view, he's one of the leading, maybe the leading researcher in Europe on this issue of digitalization in not only in schools but in educational contexts. And we are looking forward to your presentation, Pierre. And if you have finished your presentation before 11:45, we will be able to ask some questions, but we will see how it works. So thank you very much for giving this keynote, Pierre Dillenbourg.
Thank you very much. The sound is okay? Yes, I guess the sound is okay. Good morning, everyone. I feel totally ashamed not to be there. I had to cancel end of last week for children reason. So I want to talk about classrooms, and in some way this is kind of one level that has been kind of neglected, both in the technologies that we develop, but also in the research that we develop. And I start with a very concrete story. A colleague of me, this is not a real picture, of course, a colleague of mine asked me, Pierre, I have this bad teaching evaluation. Could you attend my class and see what's going on? And I went to his class, and he was only looking at the kids on the first row of the classroom, the students on the first row. He totally lost the rest of the classroom, but he did not notice that. And it does happen to all of us when we lecture that sometimes we lose attention of our students, but we notice it. He did not notice it. We notice it, and then we do something, like we make a joke, or we say, ladies and gentlemen, this actually could be a question for the exam, and we get the attention back. But he did not notice. So I thought, could I design a technology that informs him how much he has the attention of his classroom or not? And so we try to do that. We use machine learning, of course. We put cameras in front of the classroom, and we did in some way kind of a collective eye tracking. Okay, the direction of your gaze and the direction of your nose, they suffer a misalignment of about 7 degrees, but then you rotate the head to adjust. So we thought, okay, how can we compute attention? There is a problem with that. Our students are professionals in faking attention. They've been trained for 15 years. When they arrive at EPFL, they've been trained all the elementary and secondary school to fake attention. You know, they can look at you like this, straight in your eyes, and they're already on the skip list, or they're already in a party. So just the direction of the gaze of the students did not predict attention. What the machine learning found is that the predictor of attention was the fact that the heads rotate simultaneously. So it was a co-rotation of the head that was predictive of attention. How did we train the system? We stop the class every 15 minutes. We ask them how much they pay attention at the moment, how much the neighbor paid attention. This was our ground truth. It's a very subjective ground truth, but that was the best we could get. And so the predictor was the co-rotation of the head. And the explanation is simple. If the heads rotate together, because they are looking at a moving object, and this moving object is a teacher. Okay. So that's the first example of what I call classroom analytics, where we're not interested to do analytics of an individual learner, we're interested to have globally the level of a classroom. Now, Pierre, you could ask, are you really going to put cameras in schools? I know that some people do it, but I said no. I told to my team, no cameras. Even if we have a good attention, some people will use this camera for something else, so I don't want to be the guy who... We could put actually cameras that don't take any picture. They just compute in real time the co-rotation of the head and they send this numerical value, but once there are cameras, we don't know what will happen. So, but the second example, quite different, is this class of Physics 101. So we take 3% of the best Swiss teenagers and half of them will fail because of Physics 101. And this is the lecture, the recitation section, exercise session. And two guys are waiting for the TA. The TA is on the right, one is doing nothing, one is continuing to work. Where will the TA go? She will go to the person who was doing nothing to be able to grab the TA. So we notice that in this very selective first year classes, 62% of the waiting time, when they wait for a TA, they do nothing. That's very ineffective. So we designed this little lantern that you put, that the teams put that on the desk, teams of 2, teams of 3 or 4. The color indicates which exercise they are doing. Like blue is 1, yellow is 2, red is 3. Why? Because everything is everybody is working on exercise 2 and I am already on exercise 6. Maybe I can wait a bit longer. The number of LEDs, as you can see, goes up with time. Why? Because if I ask help after 1 minute, I will never become engineer. I first need to try, and when I've been trying for some time, I can ask help. Then they just hit the device and you started blinking slowly, and then faster and faster to indicate the duration of the waiting time. So we put that, this is an example of a classroom, we put that and the wasted time while waiting has been reduced from 62% to 6%. And so that's a second example where the idea of classroom analytics is that we use the physical space of the classroom and the collective space to collect information to improve the management of the lessons. There is also another concept illustrated here, which is the notion of modest computing. This device, it's not smart. Everything has to be smart today. This device is not smart and people like it because it's simple. You know what it does. There's only one functionality and it has a low resolution. We could indicate exactly the number of exercise and the waiting time, but in some way, by being a bit fuzzy, the TA can still decide where she wants to go, and so sometimes to make things more socially acceptable, you have to reduce the functionality and the resolution, having a simple device. So you all heard about learning analytics, the application of data science for individual learners. And here in classroom analytics, it's not the state of one individual learner, it's the state of n students, but it's not the state of knowledge, it's the state of activity. So it's something more shallow. While in learning analytics, we try to have a cognitive diagnosis, whether the learners understand or has acquired skills or has acquired a piece of knowledge. And in learning analytics, the goal is for the system to take a decision, to adapt, to provide a more difficult or an easier exercise. In classroom analytics, the goal is not automatic adaptation. The goal is to provide information to the teacher, and the teacher decides. So there is a human in the loop, so we see basically the classroom as a digital system, as a digital learning environment. And you might say, Pierre, this is stupid. Everything is a system. You don't bias anything by calling something a system. My left foot is a system. My car is a system. My laptop everything is a system. What does it buy us to call it a digital system? Well, the basic thing is we have an input and an output. What is an input and an output of the classroom as a digital system? Well, usually the input is things that capture information, sensors, and the output is actuators. So in a classroom, if the kids have their mobile phone, whether it's elementary, secondary, higher education, they have by default a lot of sensors that exist in most phones, and you can buy a huge set of extra sensor that you can use for different learning activities. And then the output is usually a dashboard for the teacher. So you show to the teacher some kind of data visualization of what's going on in the classroom. I would say many of these dashboards are a bit over sophisticated because you are there in the classroom with the students. This is one we just developed now. I don't know in huge universities, but in our university, Jupyter Notebook became the universal tool. It's used everywhere. So from Physics 101, basic, simple demo of simulation to more interactive exercise as they go along the years, and to even a PhD in learning science. Everybody is using Jupyter Notebook. So if you are a teacher and you have a class with 200 students and you say, okay, now please go into this notebook and do this kind of exercise, you lose the idea of who is doing what in the classroom. And this tool that we are going to make open source soon gave the teacher an idea of who has started, who is doing exercise 1, who is already doing exercise 5, and so on and so on. So that's always the same idea. This one is quite sophisticated because it's for a classroom of people using these Jupyter notebooks, but it's all the same idea. So the goal of the system is, if you provide goal of dashboard, if you provide the teacher with information about what's going on in his classroom, especially when they use tools, you lose a little bit the vision of what they are doing. You facilitate two important things, which is monitoring the progress of the students and deciding when to intervene or not. Of course, between the input and the output, you need to have some operation, so the data are aggregated, they are compared, you produce visualization. So that's the classroom system. I collect data from my learners, and I have a lot of data that I can see with my eyes, the state of engagement and so on and so on. But there is some data of what they are doing in the digital space that I'm missing when they use a digital tool, so they are collected and aggregated for me as a teacher. And the example I gave you of the lantern is a distributed dashboard. We actually compared with exactly the same information on the centralized dashboard. There was no huge difference, except that because we have 70% of males in our university, the boys tend to see that as a game, as a scoreboard, and started to compete a little bit. But otherwise, and the distributed one was nice because you could see that the team next to you is changing color, and you would say, oh, you found a solution for exercise 3, these kind of things. But globally, whether it was distributed or centralized, the dashboard did not change a lot. Can be in real time, where you see what the students are doing now, or it can be a replay tool, like on the bottom is the replay tool of the level of attention of the classroom that I showed you before. It can be focal. Most of the time it's on a computer, but we could imagine also some very modest visualization on the walls so that the teacher can see them with his peripheral vision, because his focal vision is quite busy. It can be public, like the upper part, where the teacher uses a dashboard to discuss with the students, but most of the time it's private. It's more on the teacher laptop or tablet. And here is an example. I have only 2 examples like that. This is by Ken Erstein from CMU. I think Nicole may be in the room. Nicole was co-supervisor of this PhD. And I like it because it showed the effect of the dashboard. The effect of the dashboard is to inform the teacher so that the teacher manage the classroom better. So the goal of the dashboard is better classroom management for better higher learning gains, of course. So you see, he developed some kind of dashboard in a VR glasses that the teacher was wearing, and with no glasses, it's the blue line. The teacher was spending more time. So the vertical axis is how much teachers spend attention to a learner, and the horizontal axis is the pretest score, the number of standard deviation from the mean. So you see that at the before, using the technology, the teacher was spending slightly more attention to the better learners than to the weaker learners, while with this device that was informing the teacher of who was inactive, who was playing game instead of using the tool, and so on, who was lost, who was in trouble, the teacher spent more time with the weaker learner, that's the red line, than with the better learner. Now the dashboard is about the state of the learners, but there is one person in the classroom that is very important, called a teacher. So can you also use that dashboard to show something to the teacher herself or himself? So this is a chemistry classroom with you have 24 students working at benches, and the red dot are the time spent by the teacher in different locations. And you see, for instance, all asymmetrical. The teacher move asymmetrically. The teacher move in the classroom. Maybe he has a good reason. Maybe the better students were on the left. Maybe there was some obstacle that make it difficult to move on the left. But if you show the teacher a map of where he has been, he can try to understand whether there was a good reason or whether it was just his bias to go to one corner of the classroom. So dashboard about the student behavior, but also the teacher behavior. Here is another one. Position of the teacher. There's some part of the classroom where the teacher seems not to go. Why? I mean, he must be able to know why. And this is another one based on Ati's book about how much you have been speaking. You know, teachers always say, I will make a short introduction of 5 minutes. No, it's always 15 minutes. Can you just show to the teacher something about his own behavior? So self-regulation for the teacher, regulating the classroom, regulating himself. Then sometimes, this is not my class, but my class looks a bit like that. You stop the lesson and you ask them to do something, to do some problem-solving activity for 10 and 15 minutes. And then, when do you stop? If you say, okay guys, you have 10 minutes, and then after 10 minutes say, have you finished? Okay, I give you 1 more minute, but maybe 80% have already finished, and okay, you don't want to lose the 20%, but 80% of them are wasting time. So how do you decide when you manage a classroom? Can you have a dashboard that tells you who has finished, and if you wait 1 more minute, will you get more completers or not? That's another role of a dashboard that I use in my own class, where in red you saw the people who finished in the class, and in blue those who are working on the things. And when the slope becomes horizontal, then you understand it's not useful anymore to give more time, and then you can decide to switch to the next activity. So that's also a role of the dashboard. Especially when you have large classes and you have different activities, you have to stop one to jump to the next one, then helping timing this transition. Now, let me leave university and go to Berufsbildung. I'm proud of this word because that's the only German word I know. We've been working with several vocations, and these were logistic assistants. These are people working in a warehouse and moving box as often, as fast as possible for the boss. And the teacher told us, that's different. 4 days per week in a company, 1 day per week at school. At school, the teachers say, well, logistics, optimization of storage, that's something quite complex for these apprentices who are really not schoolish at all. Can you do something to help us? So I hope you see the video. The sound is not important. I hope you see the video. And this is my warehouse. Here is where the trucks leaves when they arrives. And they build a warehouse by placing plastic shelves on the table. Teams of 3 or 4 around the table. So this is augmented reality. So the digital information is beamed on physical objects. And they can build concretely in warehouse and think about optimization storage in a very concrete way with their hands. And on the left is the exercise they have to do now. And once they're ready, they can run the simulation. And And you see the forklift, they go and pick the boxes in the trucks and bring them to the shelves. There you see the average time to move a box from the shelf to the truck. That gives you the performance of the warehouse. But yes, apprentices don't talk about performance optimization. They are very concrete. Okay, how to load a truck in the reverse order of deliveries while maintaining the center of gravity of the truck, the levels low, and so on and so on. So the teachers told us, it's really nice technology because you can explain things which are difficult to explain. The apprentice said, well, this is super cool, can we take a picture, sir? And yet, so enthusiastic students, enthusiastic teachers, no significant effect as compared to paper. Yeah. In my lab, we design cool things, we test them, and then we cry because there is no magic in education. So what happened? Why is there no effect of this super interactive simulation as compared to paper? Same learning activity, and this is an observation. We had these 4 lamps in the classroom, and we studied. We analyzed the video to see what they were doing, and we analyzed the collaboration quality, how much they discuss what they are doing, but then how much they reflect, how much they discuss in a reflective way about why a warehouse was faster or smaller than the previous one, a warehouse layout. And you see that the weakest group, they don't really discuss, they just play. They were tinkering. They used things, they run simulation. They could do it for 20 years without learning anything. So there was a lack of the technology was not forcing apprentices to think carefully. They were more playing with it. So we gave this paper key to the teachers. And the apprentice could not run the simulation. They had to call the teacher, and the teacher would say, so the simulation was locked. They would call the teacher would say, do you believe that this warehouse will be faster than the previous one? And apprentice would say, well, we don't know. And then teacher would say, think about it and call me when you know. And then they would say, yeah, we think it will be faster. And the teacher would ask why. Predicting is one of the best learning activity. And once they make a prediction, the teacher would say, let's see if this is true. And he will show a card to the lamp that will unlock the simulation. They could run the simulation. And with this and other tools, this was a dashboard that the teacher used to do 2 things. First of all, the yellow to red color was indicating whether the apprentices were tinkering too much or whether they were thinking between 2 activities. And then the teacher could, for the debriefing activity, select 2 warehouses designed by 1 team or by 2 teams and compare the performance. And so you see the left one has an average time, this is in French, of 150 seconds per box to be carried out, for 130 for the second one. And so the upper part of the dashboard was monitoring the problem-solving part, and the second part of the dashboard was helping the teacher to connect the debriefing lecture to what they have produced in the problem-solving activity. You will have a talk by Manu Kapoor tomorrow, I guess. It's about a time for telling. We let them try to solve the problem. They may not succeed, but then there is a time for telling. But this lecture should not be disconnected from what they have done. So here, with this dashboard, the teacher could connect this more conceptual explanation to actually the fact here of comparing 2 warehouses that they have different performance and trying to ask them to explain why one was faster than the other one. And with this tool, we finally got a significant effect of the augmented reality system. So the 2 messages there. The first one is the role of the dashboard is also this debriefing. Debriefing, so building the lecture, giving them a problem, and then building the lecture on what they've done during the problem. this demands a lot of talent. There is a bit of improvisation. You need to be quite comfortable as a teacher in front of the class to, not to just to run through a PowerPoint as a time for telling part, but to connect to what they have done. And this dashboard helped the teacher doing that, connecting the theoretical part on what they've produced during the problem-solving part. But there is a more important message, and that's one of the key messages I want to convey. Journalists always ask me what is the effect of ñ on learning, and I always reply nothing. A tool has no intrinsic effect. And this is a perfect example. This tool had no effect on learning. We changed something in the role of the teacher and we got significant effect. Same tool, different role of the teacher, significant effect. So that's a proof that the tool has no effect. Per se, no intrinsic effect. It has a potential effect. And it's the way the teacher used the tool in the classroom, this little key that we gave him, but also the debriefing activity that led to significant effect. And I have to repeat that again and again to journalists. They ask me, what is the effect of MOOC on learning? I say, no effect. Well, good MOOCs have better effect than bad MOOCs, but it's not because you MOOC. What is the effect of robotics on education? It depends. If the students do a demanding cognitive activity, they learn. If they're playing with a robot, they're not learning. So we have to repeat again and again to the journalists that the technologies have no effect. And this example I gave you illustrate that. But even if we all agree with that, in some way we kind of still convey this, our research method still try to capture an intrinsic effect. I had a colleague, maybe he is in the room, with whom we developed a lot of research on internal and external script. You know who I'm talking about. A few years ago, he told me, hey, Pierre, and in this research, I have no teacher effect. I said, do you listen to what you said? You're proud to have no teacher effect. Why do we train teachers? Why do we pay teachers? And of course, it's because we want to show that the method is intrinsically effective, the tool or the method. But we consider the teacher effect as a bias. Well, I'm a teacher. I don't want to be viewed as a bias. And of course, a minister would like to know that if you use this method, this pedagogical method, if you use this tool, it will work with all teachers, with any teacher. It will scale to the entire land or country. No, we need to put the teacher in the equation. We need to have the classroom and the teacher in the equation. It's not all people all learners learning individually. They are in the classroom with a teacher, and this teacher is not a bias, it's part of the equation. And another example of how we convey this bias all the time. It's now we go to elementary schools. Many children have problems handwriting. First year elementary school, the teacher noticed that some kids have problems handwriting. And then at Christmas he said, well, but this kid is really slow, and then he will contact the parents, that will contact a therapist, and by Easter maybe the kids will be followed up by a therapist, and we lost 1 year, and this propagates on all school things for the kid, and because even if you have to write 5 + 5 is 10, you still have to write 5 + 5, and writing takes, for some children, some attentional resource that cannot use to make 5 + 5. So 8.6% in France have severe handwriting difficulties, called dysgraphia, but 25% have some difficulties. So when they go to a professional, the professional will make a test that takes 20 minutes and to grade, and then and when two therapists analyze the same child, they only agree in 60% of the case, and so on and so on. So what we did, we developed the same test on a tablet. And we had so thousands of kids writing on a tablet. Some had difficulties, some had not. So it's like for picture of cat and dog, we designed a tool that analyzed the handwriting running machine learning. The difference between a tablet and paper is that we don't even need the shape of the handwriting, but we have the pressure, the angle, the tilt, the speed, the acceleration, all these things 240 times per second. So we have a detailed analysis of the dynamics, the fine motor skills, not the dyslexia part, not the ability to recognize the shapes, not the knowledge of the shapes of the letters, but the motricity of it. So the machine learning found things that a therapist can find, like the upper part, the static shape of the handwriting, the picture if you want, but also, as I said, the speed, the pressure, and the angle on the left is for this graphic child or child that has some difficulties, on the right for the others. I don't really want to focus on special needs here. Many kids have problems, slight problems handwriting, and if we can improve the handwriting, then we do a good job. I see some of these kids, they are broken by school. They are not even 7 years old. It kills me. As you heard, I've been a school teacher 43 years ago. And then the system extracts features like the second derivative of pen pressure. So a professional does not see the therapist does not see the pen pressure, but it does not see the second derivative. That's a power of machine learning. And it found things like some of these kids might have the same global score, but actually have different difficulties. For one of them is maybe the pressure, for another one is maybe the tilt of the pen. And then of course, doing an analysis is useless if you don't have improvement games. So here they practice the pressure, the control, the tilt by playing different games, and they practice fine motor skills without handwriting, because for them handwriting is a source of pain basically. And of course there are also games where they have to do handwriting because that's the goal down the road. And why do I tell this story? Is because every time I discuss that with a decision maker or a school director, he wants this. You should do an experiment, Mr. Dillenbourg, that compare any kids writing with your tool and any kids writing on paper. And fine, this is ongoing work, we will do it because everybody has that. Pre-test, post-test, that's what we've done all our life. Pre-test, post-test, control group, experimental group, and ANOVA, and blah, blah, blah. Now, when I talk to a teacher, I never say, use this tablet for 45 minutes. That's not the reality of a classroom. I would say, well, something like this. You have 4 groups in the classroom, one group on the table, they come and they play with this Dynaminis application for 15 minutes. The second group, they write in the sandbox. The third group, they write, each of them write in the back of their friend, and the friend has to guess which letter it is. And the fourth group, maybe they write on paper, and then after 15 minutes, the teacher say, oh, we rotate. That's the life of a classroom. And for the sake of proving the tool, we do things that do not correspond to what a teacher would do. And I do not expect the tool to have a miracle. I do expect the tool to have an effect when it's well integrated with other activities, some of them with technology, some of them without technology, some of them individual, some of them in teams. So we have this bias that we need to prove the effectiveness of a tool. It's quite funny because they never ask, did you prove that this book is good for learning? That we never get this question. We have this question as technologists, can you prove that it improves learning? But actually, behind this method, there is this belief that the tool will be intrinsically useful while it's only useful when integrated with other tools. And here is another example, back to Berufsbildung, training gardeners. If you are an experienced gardener and you see the garden on the left, you close your eyes and you imagine the garden on the right. Okay? if you are a novice gardener, an apprentice, you see the garden on the left, you close your eyes, and you see nothing. And can we practice the skill of envisioning my garden in 5 years, in 10 years, and so on and so on? So we are back to augmented reality. So we start from the garden, and Joseph is the gardener, so he throws the drones in the garden, as any gardener would do, and the drone makes a tour of the garden and capture a 3D model of the garden, so that we can bring this 3D model in the garden. Joseph is a good apprentice, he runs to his desk, and is going to do what a gardener will do, go in his garden and put trees, plants, benches, swimming pool, and so on. This is my garden. Quality of image is not great because we use free tool, and so Joseph has decided to put a certain number of trees there, and speed up a little bit. And once he's ready, he can go, see his garden, walk in the garden, come back in the edit mode, move the trees as often as he wants. In real life, he cannot say, Madam, sorry, I need to move the tree. And then he can do something quite magic, which is, can you show me my garden in summer, in winter, in the fall? And so he's seeing another magic in 3 years, in 5 years, and can I grab the sun and move it so that I can see the shadows in the morning? That's a nice tool that we've been testing in school, as all of them. And 2 comments on that. The first one is call it reality. No, the value of this tool is not reality. It's how we escape from reality. Like for the logistic simulation, in the real world you cannot move shells with 2 fingers. But the goal of augmented reality is to bring something different from reality, because we have the reality. So in this case, changing season, unless you are God yourself, that's not something really possible. And okay, that's just a comment. But my point was the following one. We went to schools and we tried that. And we had 2 activities. Sketching the garden on paper and building the garden on VR. And we did a counterbalancing thing. So half of the teams were drawing the garden before using the VR, and the second half did the other way around. And the result were not the same. The garden design that have been evaluated by 2 teachers in terms of these are the 3 histograms: the proportion, the composition, and the creativity of the design. The product, the design gardens were better, as judged by gardeners, when they started by the drawing activity before the VR activity. So again, for the sake of proving that the tool is good, we should use the tool alone. But no, in real life, the tool was better when the teacher would ask, first you draw it and then you build it. And that's what I call, I will not call that a myth, but we propagate the myth that if we try to have a technology as the main experimental factor, we propagate the myth that this tool, this technology has an intrinsic effect. It's a kind of embedded in a method. By using the technology as the main independent variable, we convey the idea that, of course, the causality effect that this independent variable, this technology, will cause learning effect, while actually we've seen 2 examples where it's a teacher, the teacher has a more important effect on the learning outcomes, and second, the activities before and after had an effect on the learning outcomes. So in some way, why is Popeye the sailorman on this graph? Because, as you know, there is some iron in spinach, but not as much as we believed. So it was a typo. When they were transcribing the result, there was a 0 missing after the comma, and so the people believed there was 10 times more iron than it was actually in the spinach. But But I know there is a normal amount of iron in spinach, but yet, because for the first 20 years of my life, I was watching Popeye the Sailor Man, and my mother was telling me, please, Pierre, eat your spinach because it's full of iron. So even if explicitly I know there is no much iron in spinach, it's kind of in me. And the same problem with these intrinsic effects of technologies. In some way, we all are smart people and we say, no, of course this tool has no effect. Of course it depends on how the teacher will orchestrate. You see the von Karajan example on the left. This classroom management, I call it classroom orchestration, it's more sexy, but how the teacher will orchestrate the classroom, how he will, for instance, force the learner to reflect, to predict, as in the logistic example. So we know that the teacher talent in orchestrating the classroom with our technology is a key variable. We also know, we all know, we are smart people. We know that the activities before and after will have an effect on the final outcomes, but for some reason, we want to isolate the technology as the independent variable. And by doing that, we unconsciously continue to propagate the myth that the tool that we develop have an intrinsic effect. That was my main message. So two messages. The first one is the classroom can be the input and the output. That's what I call learning analytics. But then a drift towards the fact that our methods should encompass. So people will say, oh yeah, it's a pedagogical context. When we use the word context, the context is infinite. It's a classroom, it's a school culture, it's the Lander culture, the Lander policy of education. Context is an infinite number of circles. There is no end at the context. I'm talking about the classroom context, so the role of the teacher, the other activities of the lesson. This is kind of a near context, not the infinite social context of a classroom. And with this, I stop my talk. Is there?
So thank you very much, Pierre, for this insights into your research, and thank you also for these clear messages at the end of your presentation. So now the floor is open for questions, comments. I guess you can't see the auditorium here, Pierre, but people are still thinking about the messages you have just told us.
There is nobody in the room. That's it. Tell me the truth. Tell me the truth.
But let me start with one question, Pierre. When we talk here about introducing digital media in school, we sometimes think about the teachers and their acceptance of digital media in school. And you have presented your work on these dashboards, for instance, that can be used for getting information about learning status or whatever it is of the students. Have you any, or do you have any experience with it? I'm sure you have, with the teachers, whether they like to use these tools or whether they're afraid of these tools, threatening them?
I think 99% of the dashboard I've seen are too complex for the teacher. Because basically we want to kind of reduce the cognitive load by providing them a summary of what's going on. But to reduce this cognitive load, we increase the cognitive load by giving them a lot of information. So the example of the so I think minimalism is the rule number one for designing dashboard. Minimalism, like for the attention things, it would have been just like a speed meter. How much attention have you got? Now you've seen the one for the logistics. The teacher was using quite a complex dashboard with comparing warehouses. And I said to the PhD student, Sondolaine, I said, oh, your dashboard is too complex. The teacher will never manage to to do it. And they did. Several teachers use it. And the answer is co-design. They design incrementally this dashboard for the teachers to show exactly what the teacher was willing to use, what was finding useful. So we cannot blame teachers for not using technologies if our technology makes their life more difficult. If you give me a technology that gives my life more difficult, I will not use it. So we really have to strive for minimalism. We use a lot of paper, for instance, because paper is quite easy in classroom. It's concrete, you can distribute, collect, and so on. So, yeah, quite often all technologies make the life of the teacher, just do you need to come 10 minutes before in the lesson to install everything? Well, 10 minutes before, you wanted to have a coffee because you just finished the previous lecture, and so we have to pay attention to all these small things that may make their life more difficult.
Okay, thank you. There's a question. I hope that it will work now with the microphones.
Hey, thank you. Can you hear me?
Can you hear him?
Now maybe you repeat the question.
I can repeat the question if I understand it. Maybe not.
And now? Okay, it's better, I think. So, can you hear me now?
Definitely not. But ask your questions and I will, hopefully I will get the question and then ask Pierre.
Okay, I see. So, I want to discuss the last message about intrinsic effect. So, the question here is, of course we want to compare tools. We want to compare intrinsic effect, because without it, we can't compare tools, different tools, And if we'll put it the other way around, if all the tools are same in this idea of intrinsic effect, it means that whatever tool the teacher will use, if the teacher is decent, him or herself, it doesn't matter. And then why bother in the first place? Why we need different tools for that then?
So the colleague was questioning your message, Pierre, that these tools do not have an intrinsic effect, but from his point of view, he said if you want to compare two different digital tools, you are typically interested in the different intrinsic effects. And there was some more in his question, but I have a little bit shortened his question. I hope that this was the main message of your question, or the main question, that when you question the intrinsic effect of tools and you want to compare different tools, how can you manage it?
Well, quite often, of course, if there is a single difference between two tools and we use them without any intervention of the teacher. In a classroom where the teacher does nothing, it's just the kids alone with the tool, and then another set of kids alone with the other tool, and there is causality. In real life, we have teachers, and the role of the teacher is to manage a classroom where kids use digital and non-digital tools. If we think about the tools where the teacher needs no intervention at all, it does nothing, absolutely nothing, I think we're on the wrong model. And Ken Rothstein, which I mentioned, so he was looking at classroom using an intelligent tutoring system developed by CMU, and he noticed that sometimes the teachers were actually leaving the room. They say, okay, the kids are doing nothing, so they were going in the corridor, and of course the kids would switch and stop using the ITS and playing games instead of doing email or whatever. So if we talk about the real life of a classroom, the effect of the technology will not depend only on the technology. I think the best way to describe the technology is affordances. There is a potential effect. But whether the design of the, we could say augmented reality can afford learning activities that have interesting properties like simulating a warehouse. This is a potential effect. The actual effect to be measured in the experiment will take into account what's going on in the classroom, how much time they spend, what the teacher gives them as instruction, or the teacher does debriefing, and so on and so on. So you can remove the technology from any context for the sake of publication. You say, okay, I will totally freeze the classroom context. But then the result of this experiment will not predict a policy. It will not predict what are the actual learning outcomes that will be formed when you scale this technology to 200 classrooms. If you isolate totally for the sake of the experiment, you can bring the kids in the lab or in their classroom, but controlling all factors, that will not predict the real life of the technology later on.
Mm-hmm. Thank you. I see that there isn't any more questions, so I would like to thank you again, Pierre, for this keynote, for the start of our conference. I think this was a great input for our conference, because many of the presentations, or a lot of symposia and presentations, will also deal with the role of digital media in school. So thank you very much. I wish you all the best for the future and enjoy the rest of the day. Thank you, Pierre.
Thank you. Thank you very much. Bye-bye.
So, und wir haben jetzt Zeit, in Ruhe zu wechseln zu den Positionsreferaten, die in den Gebäuden OS 75 und LS1 sein werden. Alles fußläufig, seien Sie pünktlich, damit wir um 12 weitermachen.